Before Tesla or autonomous vehicle really came into the picture, for a long time, development was, we didn't see any drastic changes. And then once come Tesla, the whole electrification of vehicle, all these things are promising massive change. Today, I have a real treat. I have Brad Maggard. Brad, welcome to the Autonomous Vehicle Safety and Security Podcast.
Thank you. Very pleased to be here.
So you got to know, there are three things you definitely should know about Brad today. Brad has been working since the age of 12, and he has paid his own tuition at Purdue University and then at Kettering. The second thing you should know is in 2016, he was induced into the Purdue Engineering Co-op Hall of Fame for his lifetime achievements in the industry built from the Purdue education. And finally, Brad has worked in automotive industry since the age of 19, and he lived in 3 continents and traveled across 65 countries. And I could go on and on and on, but Brad, I'm gonna actually give it over to you to talk a little bit about your background. I mean, how did it happen that you have been able to make your own tuition since the age of 12? You've been working. You are in your lifetime achievement has gone to Purdue Hall of Fame, and you have done so much for the automotive industry. Please tell us how it got started. What sparked the engineer in you that led to all of these?
They say necessity is the mother of invention, and that's really truly the situation in my life. I came from a lower income, middle class family. My father was actually involved in the automotive industry in 2 different capacities, but there were times when I had to help, make ends meet in the family, and that's why I started working at such an early age, along with my brothers. And we did everything from construction work to mowing grass. We had 23 yards we mowed during the course of a week. And basically, work ethic was just something that was taught to us at a very young age. Again, because that's what we needed to do to make ends meet. That led to the situation where I was the only one in my family that elected to go away to university, and I had saved enough money working the jobs during high school. During high school, I actually worked 32 hours a week while I was going to high school, and that money that I saved allowed me to get into Purdue University. But halfway through the first year, I didn't know how I was going to afford the rest of it. So that led to getting involved in the cooperative education program there, which is a work study program. And from the summer on, then I alternated every semester between work with an industrial sponsor and going back to get my education. While I worked during the semesters that I trained at the time, it was Delphi Corporation. I also took evening classes, so I was able to accelerate my graduation. Upon graduation, I opted to stay with my co-op employer. I had about 13 job offers. I was very fortunate at the time, mostly in the semiconductor manufacturing and defense industries. But again, given my background, the prospect of living on the West Coast with a very high cost of living versus being able to make a commensurate wage and working in the Midwest with a much more affordable cost of living drove me to stay with Delphi, which was a division of General Motors at the time. And so, from there, I started working in semiconductor manufacturing, did that for about 7 or 8 years. One evening I was playing basketball in an intramural league and happened to learn of an opportunity in finance within the same company that was being prospected by the director who was in charge of employee development. And I was recommended the next day and moved out of engineering into finance. And then ultimately, through a series of fortunate events, I was able to move overseas to Europe to start up our manufacturing operations and commercial operations in Europe in 1993. Worked out of Wiesbaden, Germany. And then in '96, I moved back to the U.S. into a position in Detroit, working with our customers, because my mentor had always told me the two things that a young person needed was international experience and customer contact experience. So I followed his advice. And then one summer, I was working alone and got a phone call about my next opportunity, which turned out to be in Tokyo, Japan. A few months later, I was living in Tokyo. That led to another 23 years overseas with two different assignments in Tokyo and an assignment in Thailand sandwiched in between. Going back to the recognition I received from Purdue University, it was when I was in Thailand that I was contacted and asked if I was interested in applying. I did, and really it just recognized the level of achievement that I'd attained in my career up to that point, including starting a couple of our businesses in India and Indonesia. And so I was able to go back to my alma mater and be recognized with a peer group of about 5 other former alums. And that's something I'm quite proud of. Purdue University, for those outside of the United States that may not know, is now recognized as the top 6 public university in the world, #1 most recognized public university in the United States. It's also recognized as the most innovative, or one of the most innovative companies, the only university on the list of most innovative companies. So over the course of the last, dozen years, they've also kept tuition frozen. So there's just a very good public-private enterprise and a leadership team that has done a great deal of things there. The education at Purdue in metallurgical engineering, combined with the master's in manufacturing management and the first assignment I had overseas, have really led to a career working overseas in a variety of capacities, from sales to operations to public relations and engineering.
So I mean, there's so many things you brought up, and I have so many questions. So at the age of 12, you start working because that was the necessity. And then you go to college and you use the money for the first semester, you use the money that you've saved ever since you were 12. Did you take student loan?
I did take student loan. My wife can tell you exactly how much it was because she wrote the check every month once we got married. So I didn't have a huge loan debt. I think I was paying a little over $100 a month. And that's what was so great about the cooperative education program. I was able to earn enough, and I was going to a public university, which was a land grant, that I was able to defray most of those costs.
Next question. How was it possible that you start working at the automotive industry at the age of 19?
Well, that was part of the cooperative education. So, I went to university when I was 18, turned 19, started working in that cooperative education program. So by the time I graduated, I had about 2.5 years of actual experience. And that started when I was 19. So the summer after my freshman year, I started working. And there were nights where I would pull all-nighters. I would, basically work a 12-hour shift, and then I would drive to the university for some social engagements and then drive back and take a shower and go to work.
Wow. Now, let's just, let me ask you a question about your experience from the age of 19 all the way till today in the automotive industry. My question is, before Tesla or autonomous vehicle, electric vehicle really came into the picture, for a long time, the development of automotive industry was sort of incremental. We didn't see any drastic changes. And then once come Tesla, the the whole electrification of vehicle, then we have autonomous vehicle. All these things are promising massive change, massive change. Now, what's your assessment? What was the reason that and before these two events happening, we didn't see massive changes, only incremental changes, or is my assessment wrong?
I think it's largely correct. I would argue that in the 80s there
Mm-hmm.
was a large transformation when electronics became a significant player in the automotive industry. You had a lot of things controlled by regulatory environment, whether it be Euro emissions or in-cap for safety. So you really there was a time in my career where we were hiring 300 engineers a year and had trouble, accommodating all of them because the growth was so large. And that was just in the electronics division, because we did all the electronics for General Motors, and whether it was ABS or airbags or radios or telematics or OBD2 emissions controllers, there was just an explosion and also a change in the vehicle architecture with electronics back then. But it was a little bit more incremental than what it is today with the autonomous, skateboard architecture. I think the two things driving the revolution today, and there's more than two things, but one thing is that as vehicle manufacturers look to shift from internal combustion engines to pure electric vehicles, it totally changes the structure and the underbody of the car because of the need to accommodate the battery system. And when you can take out a lot of the mechanical linkages and a lot of the superstructure in the car that's there for the mechanical internal combustion engine, then you have basically a clean sheet of paper in terms of designing your electrical architecture. And you can optimize for an entire platform. The other thing is that when electronics were growing in the 80s, there wasn't really such a focus on large scale common platforms or architectures. So that's the other thing. And then the third thing I think would be the growth in silicon and low cost electronics, such as cameras. The cost of cameras have come down dramatically. So between the LiDAR and the optical cameras, the sensor fusion and the software development, those things are really driving the advent of autonomous. And so the electrification of vehicles is a big driver in autonomous from a vehicle architecture standpoint.
Now, so fantastic assessment, how the whole thing developed. Now, there are I divide, OEMs into two categories. Like we have legacy OEMs like Ford, GM, BMW, Audi, VW, Toyota. Some of them existed over more than 100 years, some of these companies. And then you have those Tesla, Rivian kind of manufacturers. Now, do you see an existential threat or a disruption in the automotive industry because of three things? Not only because of those new players, also Chinese electric vehicle, they improved drastically. They're making amazing vehicle, and with a price tag of $10,000-$20,000 US, which is unheard of. So how do you see the whole thing developing? What will be the future of the traditional OEMs and the OEMs like Tesla, Rivian, the new generation OEMs, and somehow a Chinese disruption that everybody's talking about?
I think you're fair in categorizing the two large groups of legacy versus new energy vehicle manufacturers. The Chinese somehow play in the middle, because if you think back to the early 90s, it was a nascent, infant industry, and they started in internal combustion engines. It's still a very immature industry. There's probably more than 100 vehicle manufacturers in China. The consolidation hasn't really occurred. But the advantage the Chinese have capitalized on is that they've been able to come at it across industries. They don't have a lot of installed capital in a lot of the vehicle brands that exist today. So there's not a major redeployment of resources and reskilling required. They're just starting from scratch. I think the biggest challenge that the legacy manufacturers have today is, one, reskilling. They have very large workforces that are not ready for the new energy vehicles. You have a lot of very, very capable mechanical manufacturing engineers, engine manufacturers, etc. But you've got to have a great capability and competency in software and electronics in order to drive the autonomous wave and to drive electrification. There's also a huge issue with resources, recapitalization, and redeployment of existing capital. So a lot of the new players are basically only investing in the new business, where the legacy players have to balance between the old and the new. And while some of them have been very quick to invest in new energy vehicles, the uptake has not really been there to support the cash flow that's required. So if you look at electrification as an example, it's led by China. From a vehicle production standpoint, maybe 37% or so of their industry is pure electric vehicles. The United States is, maybe only 7% on pure electric and 11% on hybrids. You have countries like Norway that are 75 to 80% electric, because they don't have this issue of an installed capital base, and they don't have a domestic industry to protect. So that's the other element that comes into this, is the role government plays in either incentivizing or protecting the transformation.
Gotcha. Super interesting. Now, with all these, electrification, autonomous thing happening in the next 10, 20 years, what do you think would be the most positive impact of these new emerging changes for the society at large?
For sure. The greatest impact, I think, that autonomous vehicles are going to have is saving lives. I mean, I think the vast majority, it's well understood, the vast majority of fatalities and accidents are due to human error. And while people are skeptical, sometimes wary of autonomous technologies, the data will prove out that machines make better decisions faster if they are properly designed and programmed. So I think the roads will get safer. You will be able to, we're getting there now, but you can have autonomous vehicle platoons in addition to the safety, where the vehicles are talking to each other and keeping the necessary distances, etc. People will be able to grow their productivity because you will be able to multitask in the vehicle. We're not there yet, and I don't suggest anybody do that. But you will be able to do anything from office work to shopping. That's one of the big interests that a lot of companies have, is to capture that captive consumer in the vehicle during a 3-hour drive. And then on the electrification side, I think, ultimately it will move towards making a greener planet. I think the transition, my personal opinion is the transition through a hybrid solution is a better transition, because it's less disruptive. It's in some cases a better use of the limited resources we have in terms of the battery materials, rare earth metals, etc. And I think the industry also, as a whole, the consumer is not ready to go pure electric. If you have a second vehicle, or you're using your vehicle only for commutation, I think that's great. But in large economies like Australia, China, the United States, I think the fear of not having the fuel that you need on demand is still going to be a limiting factor, and that's where hybrids cut emissions, but still give you the opportunity to have the range that you need to take your holiday.
Totally, totally. I could totally agree with you there. Once I was in Gothenburg, Sweden, actually visiting Volvo, and on my way to the airport, the taxi driver asked me, "What do I do?" And I told him, like, I work with, electric vehicle, autonomous vehicle, and all those safety and security. So he told me one thing. Look, I mean, I'm not going to drive an electric vehicle. I said, why? Why wouldn't you drive an electric vehicle? Because then he answered, I'm going to only drive an electric vehicle when the range will be 1,000 kilometers and I can charge within 5 minutes. If that's not insured, it's just not practical for me. And that made me think, okay, we do have a lot of work to be done before we make it really viable for everyone. My last question to you would be, you had a glorious career. If there's one thing that you would like to share with our audience that would be a lesson for engineers, automotive professionals, or whoever is in automotive business, what would that be?
I think we can accomplish a lot more by working in a collaborative win-win relationship. I think too often vehicle manufacturers and suppliers don't have the right relationship to produce the best results. I mean, I think and too often the systems are set up for win-lose outcomes as opposed to win-win outcomes. And when you're going through a transformation like we're going through now, the efficient utilization of resource or economics is absolutely critical to everybody involved. I mean, the burden on suppliers is huge right now. The burden on OEMs is huge right now. You can't afford the waste. And so between the suppliers, between the vehicle manufacturers, with the support of the government, I think it's the best possible scenario for the right outcome. The other thing is that we shouldn't be scared of technology, but we should be wise and aware of technological issues. I read an interesting article just yesterday where in the United States, as an example, there's a lot of controversy around the application TikTok for foreign surveillance, etc. But the application made the point that, vehicles can be weaponized. And I hate to say it so directly, but with the autonomous technology, they're basically a roving surveillance machine that have the ability to capture tremendous amounts of data and transmit that data. And of course, we know of the hacking risk and threats of vehicles as well. So the use of technology for good to save lives is critical. I think it's a major contribution to society, but I think we need to be cognizant, aware of things that can go wrong, and make sure that the appropriate safeguards are put in place. I think yesterday the world, or today, depending upon which time zone you're in, experienced a major outage due to a cybersecurity company doing an update on its software that crashed the system. And everything from banks to airlines to Starbucks to who knows were taken down. So you have a situation where, in an effort to prevent the wrong use of technology, technology itself disrupted society. And so we've got a long way to go. But the best way to get there, coming back full circle, is full cooperation and collaboration for the benefit of mankind and not just for the bottom line.
Totally get it. The way tier ones and suppliers and the OEMs, they collaborate, we could do a lot better there. The collaboration, if it is more, as you said, collaborative than competitive, or looking at the bottom line, we could actually, that would have improved the bottom line of all the companies, all the supply chains. Wow, that was amazing. Really, really amazing to have you, Brad. Thank you so much for being with us.
My pleasure. Thank you.
Thank you so much for watching. If you have any question, comment, please feel free to write in the comment. Either someone from our team or even Brad will be more than happy to answer your question. Thank you for being with us. See you in the next episode.